All right, so welcome back to Blockchain Mastery University. So this week I'm going to give you an introduction to EIP 1559, and we're actually going to get our hands dirty and look at some code related to this and how you can actually integrate your projects and create something around EIP 1559. And so, off the bat, if you're kind of confused, like, hey, what is EIP 1559 in the first place? Why does it matter for me as a blockchain developer? Well, I'm explaining that in this video and then show you how you can actually write some code with it. All right. So let's just go ahead and jump in here. What is EIP 1559? Well, let's just break it down. EIP stands for Ethereum Improvement Proposal, and that basically just means a document that says, hey, we want to change the Ethereum protocol in some way. Okay, so that's how Ethereum works. It goes through something called decentralized governance. So if you want to change something about how Ethereum works, you submit these things called Ethereum Improvement Proposals, which are just a document like this, listed on a website like GitHub. Okay. And then basically a bunch of people vote on it, and if it passes, then it gets included into the Ethereum software that runs the public blockchain itself. And that's basically how Ethereum undergoes changes over time. It goes through this Ethereum improvement proposal process. The proposal gets implemented by the decentralized community of developers who maintain and build Ethereum, and then it gets included in the blockchain whenever their clients update it. So that's what an EIP is. EIP 1559 is just a number. It's a specific number for improvement proposal that's designed to be a user experience upgrade for the Ethereum network. So one of the biggest problems with Ethereum right now is, whenever you go create a transaction or prior to EIP 1559, there's a lot of problems with gas, being highly variable. You got all these confusing settings that say, it should be slow, medium, fast, right? And it really confuses users, and sometimes it results in people overpaying for gas. And so one of the big benefits of EIP 1559 is a user experience upgrade, which we have more consistent gas pricing, and we don't make it confusing for the users to actually do that. So basically, if you see your wallet like MetaMask, post EIP 1559, you want to create a transaction, let's just go to a test network here. Let's see, you want to send some ETH, let's just send it to an account here. Let's just say you want to send 0.001 ETH, post EIP 1559. Well, actually, see, I think it's already implemented here. So you can just see that you don't have these slow, medium, fast settings anymore. You just click confirm, and it works, okay? So that's basically the benefit here. So that's one benefit. Now, another thing people are super excited about with EIP 1559 is that ETH is actually going to get burnt whenever new transactions are created, and that can, of course, have a positive price impact on Ether, or positive impact on the Ether price long term. Basically, if we have enough transactions on the blockchain, then if enough ETH is used enough, we can actually start burning ETH and supply, make the cryptocurrency more valuable. So how does that work? Well, basically, whenever you are creating a transaction in the Ethereum network, let's say I did this transaction on MetaMask, maybe I sent one ETH from this account to this one, okay, that fee is going to get split into two parts. So a base fee, all right, and then a minor tip, okay? And this base fee right here actually gets burnt, all right? It gets completely erased from the network. And this minor tip, of course, goes to the miners who are on the Ethereum network right now, and they are going to basically be paid this way, all right? They're also paid by the new ETH that's created by the blockchain whenever new blocks are mined, but in terms of our transaction fees, they get paid with this minor tip, but this base fee goes away. So you can actually inspect this on Etherscan. You can watch this happen in real time. You can go to any latest transactions, all right? You can just click on a random transaction here, and you can see that, let's see here. It's probably easier to see on the, it's actually easier to see on the block itself. So go to the block level, go to this block right here, and you can actually see the burnt fees right here in every single block. So you see 0.049012, etc. Ether was burned in this entire block, because again, a block is just a grouping of transactions that gets created whenever new block is mined and put on the blockchain. That's how blockchains work. That's, the transactions are grouped into bundles of records called blocks, which are chained together to make a blockchain. And here you see that 0.04 ETH is burnt inside this block. You look at another block here. Look at this one for F2 pool. 0.8 Ether was burned in this block. 0.9 Ether was burned in this block. All right. And these blocks are happening every few seconds on top of the blockchain. So that's, you can see this really adds up. And so you can look at a website like ultrasound.money here, which actually shows you the cumulative amount of ETH burnt since EIP 1559 went live just in the past day or so at the time of recording this video. Okay, now of course by the time you watch this, if you're watching much later, this number will be much, much larger. But this website gives you an idea of how that works, okay? And you can also see the latest blocks here, all right, and the amount of ETH that was burned inside of each one of these, all right? So you can see 0.358 ETH here, 2.16, et cetera. So now what I want to show you how to do is actually code a script that works a lot like this, okay? Where you can basically see, this information. I'm going to show you how to inspect blocks on top of Ethereum, see the amount of gas actually getting burnt, the amount of ETH actually getting burnt in each block, how to calculate it, how to create a script that works a lot like this website. So let's jump in and get our hands dirty and start coding. So you can see a link down in the description below to basically to a file, okay, or some code. And then go ahead and open that, all right? And what this is a project template that is just a Node.js script. Okay, you can go inside of here, you can see it's just got a few files. Got an index.js file here, got a package.json file for the dependencies, got a .env.example file here inside of here, and really just these three main files that we want to look at. So the script, what it's going to do is going to talk to the blockchain, and we're actually going to create a script that can just fetch every single block from the blockchain as they update and display information just like this. We're going to look at each block, log out the number, show the amount of ETH burned, and then calculate the cumulative ETH burned since we started running the script. Okay. So go ahead and download that, and then open up the index.js file here. You'll probably see a complete code solution, but I'm just going to take out, basically whatever's inside of there, so we can code it from scratch and just take out this part. Okay, so we can start from the top. And we'll create this step by step here. So what you need to do in order to run this is first connect this to an Ethereum node. So you can just go to Infura. We can use Infura, so we have to run Ethereum ourselves. Just go to Infura.io, create an account. All right, go to your dashboard, look for an app. Okay, go to settings, and then find your project ID for whatever app you've created. And that's I'm not going to show them on screen here, but that's going to be your Infura API key. Okay, so you can see you can store that in a .env file. Here we got a .env.example file, so you can just get a new file and call it .env. All right, and then save it, and then put this exact information inside of here. Do your Infura ID, and then backspace this, and actually paste in whatever it is, ABC123. Actually put that as your actual Infura ID here. Okay. But not in your .env example file. Do it in this .env file, this new created one right here. I'm just not going to show mine on screen because that's secret information, and I'm going to keep mine private. Okay. So what we're going to do, though, is actually set up this script. First, we're going to load the environment variables from our .env file, which is saved here. We're going to make a connection to the Ethereum node with Web3.js. That's this here, constant Web3, require 3. And then we're going to do RPC URL is mainnet.infura.io/version3. And then we add our Infura ID right here, okay? And so then we say Web3 equals new Web3. We paste in our RPC URL. And now we can start talking to the blockchain, okay? So the first thing we want to do is actually just pull the latest block on Ethereum. Okay, so I'm going to do this. Say Web3 ETH get block. Okay, say latest, and say then, and pass in a function. And inside here's like console log, and then block. And this will be a smoke test for you to make sure your project's set up properly, that you have your API keys configured. So you can just say, well, actually, first, before you do this, make sure that you have installed all the dependencies. Sorry, I meant to mention that a minute ago. So do npm install. All right, that'll install your node packages. I've already done this, so it should be fine. All right, so now you want to say node-index.js. That's just how you run the scripts. So node-index.js. Let's just make it bigger here. And then boom, there we go. Here's the information from the latest block. So Web3 lets us fetch each block and return some data about this. You can see the block number. All right, block numbers 1297, et cetera, et cetera. You can see a bunch of information, the parent hash, the transactions that are contained in the block. These are all the transaction hashes. Again, blocks are just bundles of records called transactions. Or sorry, bundles of records which are transactions. They're bundled together into blocks, and the blocks are chained together to make the blockchain. And then you can see, and here's the key data about EIP 1559. You see this base fee per gas. This is actually the amount of this is the base fee per gas that's calculated in the block, and then we just multiply that by the gas used, and that'll actually give us the actual ether amount burned in each block. So we can confirm that with EtherScan. So we can just look at this block here. Let's just look at the number. Let's just copy it, and then go to EtherScan, and then let's just look at a block. And then you can see the URL here, EtherScan.io/block, and here's the number. Let's just paste in the exact same number from that block we saw in our terminal here. So I'm using block 1297, sorry, let's just see here, 12972960. So you could use this exact block if you wanted to for this example to follow along with me and check your math and make sure it looks right. So I'm just going to freeze on this block, all right? And I'll show you how to do that inside your code so that you can replicate this. Because if I went inside the code and kept just doing Web3 ETH get block latest, it's just going to keep returning the latest block, and my calculations are going to change every time. So I'm just going to paste in this number right here and then do it again. So we're looking at the same results every time, keep running it, it's the same data, okay? All right. And we can see the block number has not changed, right? So let's compare EtherScan's results with ours. And what we want to do is replicate this number right here, right? Burnt fees in Ether. But we don't see that Ether data directly in the block, so we have to calculate it. Well, how do we do that? Well, you can see this base fee per gas, okay, which we do have right here. It just looks funny. So we take the base fee per gas and we multiply it by the actual gas per block. So where's that? So sorry, yeah, so gas. So gas used was 11 million units of gas, and then base fee per block. Sorry, base fee per gas will give us the base fee per block if we multiply these two numbers together. So let's start with what is the gas used? Well, basically, anytime you create a transaction, like I was showing you a second ago, you pay a gas fee, right? That's what you would see here, okay? And all the gas paid by each transaction in the block adds up to be the total gas in the block. So basically, 11 million units of gas were used, okay? And then, yeah, that's 11 million units of gas were used, and then basically we can just start multiply that gas per block, and then that'll give us the actual number, okay? So let's go ahead and do that. First of all, let's fetch out some of this data. We can look at the block. We can console log our specific values here. We can look at block gas used, then block base fee per gas. All right, so you can see here's the gas used in the block, and then here's the base fee per gas. Now we multiply these numbers together to get the actual gas used, but there's a problem here, right? This is not in a number format. Okay, so this is in a hex format. We need to convert it to a number, or at least a number string. So we can do it like this. We can say Web3 utils hex to number string. All right, and we can actually break this out into its own variable here. And we can say const base fee way, and base fee way. All right, and then run it again, and boom, there we go. So now we can see this in a human readable fashion, and one that we can actually do math with. So we can match this here. So base fee per gas is this, or 81 gwei. Now we can match what we see on EtherScan to confirm this is right. So now why does ours look like? Why does ours look much bigger, right? We have 81, but this starts with 81 with no decimals after it, and we see on EtherScan that this is 81 gwei with some decimals after it, or 0.0000 whatever ether. Well, that's because we're looking at the way value. So let's just see here. I'm pulling a website that will illustrate this. So this is a website that shows you the different units of ether. So ether, like if you have one ether that's worth this many wei and this many gwei. So gwei is a subdivision of ether. Wei is a subdivision of ether. You can think about wei like a penny to the dollar. That'd be a good analogy. Whereas the dollar has 2 decimal places after the decimal, or 2 zeros after the decimal place. Then ether has 18 decimals, and if you convert that to its smallest unit, that'd be wei. Now gwei is sort of somewhere in the middle. So sometimes you don't want to express things in wei. You actually want to express it in gwei. That's what gas prices are expressed in. Okay. So you can actually take this number, copy it in here just for reference, and say, yeah, it equals 81 gwei and this many ether. So these numbers match, right? So we're correct here. So now what we can do is actually calculate the burned ether. So what we do is first multiply these numbers in wei terms. Okay, so we multiply the gas used and then the base fee per gas in wei. All right, so we do like this. We can break these out into variables here. We can say const gas used wei, block gas used to string, because again we're converting this to a number string and this to a number string. All right, and then we can say const burned wei equals gas used wei times base fee wei. All right, and then we can just say burned wei. All right. Boom, there we go. So now we can actually convert this to ether with our calculator here and see if it's right. Let's see here. Pull up our calculator, put it on the same tab. Boom, there we go. So 0.93 ether has been burned in this block, which is exactly what we see here. So 0.93 ether. So now we can convert that in our script here. We can basically just say, burned ETH equals web3 utils from way. So we can basically convert it from way with this utility helper, and then say burned way to string. All right, and say ether. We want to convert it to ether. So from way, we're passing in this amount, this function, and we're telling it that we want to convert it into ether from way, and then we can console log the burned eth. All right, so boom, there we go. So that's the exact number that we see here on EtherScan. All right, so now what we want to do for our script purpose, though, is sort of make the number shorter, because we want to make it like this website where it's nice and simple, where we just have 2 decimal places. So we can do that with some math here in JavaScript. Basically, we can say, const burned eth formatted, and say we do math.round. So you can round the number first, say burned eth, and then multiply it by 100, and then divide it by 100. That'll help us round to 2 decimal places. All right, and then we can convert that to string, so that reads nicely on our thing, and then we can look at burned eth formatted in our console. All right, it's 0.94. Awesome. So now what we can do is add some human text here. We can say burned eth formatted. Eth was burned at block number, and then we can put in the block number here. So we can say block, number from block that gets passed in here. Block number to string. All right. All right. Boom. There we go. Awesome. So now what we can do is actually start looking at each latest block. So instead of just hard coding the same block every time, we know that the block information is right because we match it with EtherScan. And so now we can just say get the latest block, make it dynamic, and we can see here pull for each block. All right, there we go. So the latest block, 1.35 ETH is burned. So we can just copy that and look at EtherScan and just make sure our math is right. All right. So yep, 1.35 ether was burned. Looks like our rounding is correct. Do it again. So 1.93 was burned that block. Awesome. So now what we want to do, instead of just having to run this script every time, is we want to just check each latest block. Okay. So there are a few strategies for doing this. One is you could wire up something that polls. You could have a WebSocket connection that could basically talk to the blockchain and then auto-update every time a new block gets added with a WebSocket connection. You basically change this to a WebSocket connection here with Infura. You change how you connect Web3, and then you would sit here and just listen for new blocks on the blockchain. And you can do that for homework if you want to. Without getting too complicated, we're just going to poll for new blocks inside of JavaScript. Okay, so we do it pretty easily. Basically, every second we can just check for the latest block and compare it to the previous block. And if it's changed, then we can log new information. So we'll do it like this. We'll do set interval. So what this function does inside JavaScript, it lets us do something on a specific interval. Okay, so we're going to do it every second. Every second we're going to check for a new block. So basically, this set interval takes 2 arguments. The first argument is a function. That's what we're going to pass in here. And the second argument is the amount of time you want to wait in between running this function. Basically, you're creating an interval of 1 second long. So every second, just do whatever's inside of here. And we can break this up. So just, do something. All right. And then every 1 second, do something. All right. So what we're going to do is just copy all of our logic here and then, paste it inside of here. And I'll show you how that works. You can run it. We can say, Next.js. So every second, it's just going to check for the latest block. And you can see how set interval is working. So every 1 second, we're just, running this function. Now you'll see some repetition here. It's just saying the same information over and over again. We want to update the script to be better so that, every second we only want to log information out the screen and check. We only want to inspect the block and log out information if it's a new block. Okay. So how do we do that? Well, we can do like this. We can keep track of the previous block and compare the current block. So we can just say this previous block equals 0. All right, just as a placeholder. And inside of here we can say, if block number to string is greater than this previous block to string, then run this command. Run all this stuff. All right. All right, and then go here. And we should see it working. All right, so not quite. Let's fix it here. All right, so I see the problem here is, so we have to update the latest block, or previous block, whenever we finish this. Okay, so right now it's always running because previous block is always 0 and it never changes. And so this is always going to be true. So we want to set the previous block right here. Say this previous block equals block number. Okay, and then do it again. Wait for finish. You should log one out of the console every second here. Not every second, but every time you block's mine. All right, yep, there we go. It's working. So you can see every time a new block is detected, you can see that it will log at the console. You can see numbers incrementing automatically here. So 7, 8, 9. 0.19 ETH is burned. 1.5 ETH is burned. 0.26 ETH is burned. So that's working. So now what we want to do is actually calculate the cumulative ETH that was burned. So basically, we can see how much ETH is burned every block. But we want to create something like this where we can see how much ETH is burned in total. All right. So we're going to do this a simple way. We're just going to keep track of how much ETH is burned since we started running the script. I'll show you how to extend this later to do something more like this, a little bit more complicated. But for now, what we can do is basically just say, this.total way burned equals 0. And then, after we calculate this, we can calculate total way burned. So we always want to keep track of this in way because we don't want to add, these decimals together and create, rounding errors. When we do our calculations, we actually want to calculate the raw way itself and then add all that up first and then convert it to ether later, okay? So you can do that like this. Let's just pull it up on my screen here. We'll say this.total way burned equals this.total way burned plus burned way. Or we can see here, we've got this, okay? And then we can say const total ETH burned equals web3 utils from way, and then pass in this that total way burned to string, and then say ether. Okay, and so now we have a new console logging statement here. Console log. I say a total of total ETH burned. ETH has been burned. Save. And then watch change. All right. Wait for the next block to arrive, and we'll see that the actual total ETH amount has gone up. Wait for it to finish. Sometimes it takes a second. Yep, there we go. Awesome. So now we can say the next block's been detected. 1.38 ETH was burned at block this, 59. And then we added the amount burned here, 1.38 plus 0.6, which is about 1.97. All right. And then there we go. Same thing. Boom, boom, boom. There we go. It's working. Awesome. So for homework, what you can do, a couple things. One, you can implement rounding here whenever you actually display the total ETH burnt cumulatively. So just like we did here with the rounding, you can do rounding whenever you display the total ETH burned. You could, say formatted or something like that, do some math. The other thing is you could actually, go back in history and accumulate the total amount of ETH burnt since EIP 1559 went live. So how would you do that? Well, you can do a little bit of Googling and find the block number where EIP 1559 went live. All right, you shouldn't be that hard to find that with a little bit of research. And then essentially you would go back in time and get all the blocks from the Ethereum blockchain since that block and loop through them and log them out to the console until you get the latest block number, and then calculate that number. All right, store it inside your app, and then basically store as a variable as total way burned at the beginning. Okay, and then instead of setting it 0, so you can just go through, fetch every single block, calculate the way burned, do math, store the total way burned as a starting variable, and then whenever that's finished, then you actually start pulling the blockchain and get the latest blocks, and start adding to that number. And you can also prep this by seeding maybe the latest 5 blocks or something, and showing the latest 5 blocks or 10 blocks in a page like this, and then update this list, as new blocks are being mined. So those are some ideas. You can also use a website connection like I talked about before instead of doing set interval and pulling the data here. But yeah, that's all I got for today. That's an introduction to how you can start coding with EIP 1559. Hope you like this video, and until next time, thanks for watching Blockchain Mastery University.